Welcome back to the deep dive. Today we are tackling a fundamental cognitive roadblock. I mean, it's this invisible yet kind of pervasive psychological thing that really acts as a spoiler for innovation sometimes. We're talking about that mental trap that, prevents us from seeing a familiar object or maybe even a person in a completely new light.
Exactly. This is a deep dive into functional fixedness, or FF as we'll probably call it. And look, it's not about being unintelligent or uncreative or anything like that. It's really about efficiency gone wrong, you could say. It's that ingrained habit of memory where the known function of a tool or maybe a concept becomes this invisible barrier. It just chokes off the possibility of finding novel uses right when you need them most.
Okay, let's unpack this straight away then, because I think we've all experienced it, right? You need a weight, but all you see is a hammer. Or maybe you need a lever and you've got a ruler, but it just doesn't click. Functional fixedness is precisely that moment of interference, isn't it? Where the pre-established purpose of an object, what your memory is basically screaming at you, it blocks your ability to see its physical properties, like its weight or hardness or shape,
Yeah.
things that could actually solve the problem right in front of you.
That's the absolute core of it. Functional fixedness, I mean, the sort of working definition, is all about how that previous knowledge of an object's typical use interferes with solving problems in, well, novel contexts. So if your brain has really strongly categorized, say, a thumbtack box as simply a container for tacks, it then actively struggles to even conceive of that same box as maybe a platform or a support.
Right. And our mission today is, well, pretty ambitious, actually. We're going to trace the origins of this bias back to those classic Gestalt experiments, but then we're going to pivot pretty sharply to some really modern research that systematically defines the hard and frankly surprising limits of FF. We'll look at whether this bias is, universal across cultures, even across species. We'll examine how it can undermine complex tasks like software design. And finally, we'll explore the proven cognitive hacks and maybe environmental manipulations, the tools, if you like, that we can use to shatter that fixed way of thinking. This is really a shortcut to understanding why we all get stuck sometimes. Okay, let's start right at the beginning, the foundation of this idea. We often talk about how prior learning speeds things up, makes us more efficient. But here we have a case where that very learning actually becomes a detriment. So where does this concept of FF actually begin in, formal psychology?
Well, FF really finds its origin in Gestalt psychology, which focused a lot on how the mind organizes perceptions and problems. The truly seminal work comes from Carl Duncker back in 1945. He used functional fixedness to illustrate how prior knowledge, specifically about the intended function of a tool, interferes with finding novel solutions. And this wasn't just like an observation. It was a systematic illustration of how your mechanical knowledge, your ability to actually use the object's physical form, gets overridden by the functional classification you already have stored away.
So FF isn't really concerned with that aha moment of insight itself, is it? It's more about the cognitive friction that happens before that moment.
Precisely. It explains the why behind the cognitive impasse, not necessarily the how of the resolution.
Yeah.
You look at later studies, ones analyzing insight problem solving, functional fixedness is essentially the hurdle that you have to overcome before the insight can even happen. It describes that initial sort of cognitive disturbance that occurs when your established mechanical knowledge gets choked off by that pre-utilized functional knowledge.
Okay, to make this really concrete for everyone listening, we absolutely have to detail Dunker's classic setup, the famous box problem. I mean, this is the cornerstone of the whole field, isn't it?
Oh, it is. It's the perfect, really elegant demonstration. The task itself was simple. Participants needed to fix 3 candles vertically onto a corkboard wall. And they had to do it in such a way that the candles could be burned safely without dripping wax everywhere. Among the materials provided were the candles, matches, some thumbtacks, and crucially, 3 little pasteboard boxes.
Right, and the elegant solution involved mounting the candles on the wall by tacking the boxes to the wall first and then using them as platforms. Simple enough. But Duncker introduced this brilliant variation to actually create the fixedness.
He did. So the control group, they just had the boxes sitting there empty, next to the other materials. For them, it wasn't too hard to perceive the box as a potential platform. But for the experimental group, and this is the crucial pre-utilized condition, the thumbtacks and matches were placed inside those boxes. So by serving as containers right from the start, the boxes were instantly burdened with a fixed function.
And the results, they showed a significant delay, didn't they? The subjects in that pre-utilized condition, they struggled immensely to see the box as anything other than just a holder.
They absolutely did. Their solution times were significantly longer, and actually many failed to solve it at all within the time limit they were given. The function of container literally blocked the perception of support. And that distinction, that inability to switch between the abstract function, like holding, and the physical property, like being a stable base, that is functional fixedness in action.
We should probably pause here for a second because FF often gets confused with a related concept, cognitive set. Can we clearly draw the line between the two?
Yeah, that's a really essential clarification. Cognitive set, or sometimes just called set, involves a kind of inertia of method. It's the tendency to just keep applying a strategy that worked before, even if a new, maybe more efficient strategy is clearly available right now.
Can you give us like an everyday example of a cognitive set?
Sure, think about your daily commute. Maybe you've always taken a specific highway route. Even if your GPS now shows a quicker way using local streets that avoids all the rush hour traffic, you might just stick to the highway. Why? Well, because the known method is familiar, it's comfortable. The problem there is about efficiency, not inability. You know the local roads exist, you just don't use them because the old set feels easier to execute.
Right, whereas functional fixedness is more about a blindness to the object's actual capacity.
Exactly. FF is the inability to even perceive the necessary capacity in the object, because its typical function is overriding its physical properties in your mind. However, the concepts are definitely linked. Studies do show that being susceptible to functional fixedness is positively correlated with being unable to overcome a set. So if you're prone to that kind of methodological inertia, that set, you're often also prone to functional blindness, the FF. Both involve prior knowledge restricting your cognitive flexibility, but FF specifically ties that restriction to the object's function. Now, let's take this beyond just physical tools for a moment. I find the conceptual expansion of FF to be one of the most powerful insights here. Where else does this kind of fixedness show up, maybe in more abstract thought?
Well, we see some really striking analogs in how we process language and literature, for instance.
Mhm.
In that context, functional fixedness is kind of like the reader's habituated mind, the expectation that words and images will function in their most common everyday ways.
And metaphor then acts as the counterforce, the thing that breaks the pattern. Precisely. Metaphor functions as that cognitive disruptive force, you could call it the axe, that shatters the reader's mental habit. Think about Homer's famous phrase, the wine dark sea. Normally, wine is for drinking, right? The sea is for sailing. The two are pretty incongruous. So the brain is forced away from the typical function, consumption, and pushed towards abstract properties shared by both. Maybe color, viscosity, depth, or perhaps even mystery. The metaphor effectively repurposes the image of wine, overcoming the functional fixedness of the word itself to create this totally novel perception of the ocean.
That reframing is absolutely key. The metaphor forces us into that sort of bottom-up thinking we often need for novelty. And this applies, maybe rather tragically, to social perception as well, doesn't it?
It really does. Perhaps the most poignant social analog is perceiving a person only through the fixed function of their current role or context, failing to see their greater human potential. Think about maybe viewing an adjunct instructor only in terms of their fixed function, like a cheap source of classroom coverage, and completely failing to recognize their PhD research, or their innovative teaching style, or maybe their capacity for leadership.
Or even more commonly, perhaps, failing to see a service worker as a whole person simply because they are currently fulfilling the function of server or cashier.
Exactly. When we reduce people to just their immediate role, functional fixedness really limits our cognitive processing of their capacity and complexity. It's an efficiency shortcut, sure, for social categorization, but it comes at this potentially high cost of empathy and recognizing someone's full potential. We basically fail to recognize the abstract properties of the person, their intelligence, their dreams, their struggles, because their immediate fixed function kind of blinds us to anything else.
Okay, if social FF shows us the sort of human cost of this bias, let's go back to the lab for a bit to define its physical boundaries more clearly. The classic Duncker setup, it kind of suggested FF was everywhere, ubiquitous. But modern research has actually provided some crucial constraints on where and when this bias really takes hold. We have this detailed 2018 study by Munoz Rupke and colleagues that systematically looked into this.
Yeah, this study was really vital for placing functional fixedness in its proper context. It moved beyond just the simple box problem to test its real limits. They used a pretty sophisticated approach, exposing subjects to various mechanical puzzles and dividing them into 5 different learning groups: reading R, video V, manual M, no functional fixedness, NFF, and no training. and T.
Right, and the purpose of those R, V, and M groups was to see if the way you learned about the tool, like active hands-on versus just passive watching or reading, influenced how strong the fixation became. Correct.
Precisely. The R group read descriptions of the tool's intended use. The V group watched a video of someone using it, and the M group actually got to physically manipulate the tool for its normal purpose. But the key finding here was pretty striking. FF was generated regardless of how the tool was learned. All three of those groups, R, V, and M, showed clear signs of functional fixedness when compared to the NFF group, the one without the functional prime.
Wow. So whether you read a manual, watched a YouTube tutorial, or actually built the darn thing yourself, the cognitive bias that followed was basically the same.
Yes, essentially. This really confirms that it's the misleading functional information, that semantic label that gets attached to the purpose, that's truly at the core of the bias. Whether the manipulation knowledge was active or passive didn't seem to significantly modulate the generation of the bias itself. It's the fixed label, not so much the muscle memory, that seemed to do the damage.
Now here is where the research gets really counterintuitive, and frankly, it kind of limits the power we often ascribe to FF. What did the researchers find regarding the difficulty of the puzzles?
This was probably the most surprising revelation of the study. Munoz-Rubke and her team found that functional fixedness only created a significant cognitive impasse in simple or very easy mechanical puzzles. You know, the kind that might take just a minute or two to solve anyway, like their scale prop or scale balance tasks.
Wait a second. So if a problem is highly complex, like their marble push or weight wheel puzzles, you're saying the fixed function of a component didn't really play a significant role in blocking the solution.
That's exactly what the data showed. Functional fixedness did not have a statistically significant effect on problems of higher difficulty. The researchers proposed that maybe when a problem is already significantly complex, the human brain automatically shifts into a much broader, more abstract, and sort of less constraint-driven search process from the outset.
Huh. It's almost as if once that complexity threshold is crossed, the brain just assumes the most straightforward fixed function of the tool won't cut it anyway. So it starts analyzing the object based on its raw physical properties almost immediately.
That's a very elegant way to put it, yeah. The sheer difficulty might force the cognitive search space to expand so rapidly that the fixed function becomes just one minor constraint that gets quickly discarded, rather than being the primary barrier it is in simpler problems. This really radically restricts the role that functional fixedness might play in major engineering challenges or big creative tasks. It seems it's largely a bias affecting simple, immediate problem solving.
That has huge implications for things like design and brainstorming, doesn't it? If you're stuck on a really complex issue, FF probably isn't your main enemy. But if you're stuck on something simple, it probably is. Did the study also reveal how long this bias actually lasts? Is it persistent?
Yes, and this is another piece of potentially good news for the listener. The effect of functional fixedness was restricted almost entirely to the first attempt at solving the puzzle. After an initial failure, when the subject realized their first fixed strategy wasn't working, the bias seemed to rapidly dissipate. It didn't significantly affect performance on their second attempt.
So the immediate failure itself acts as the shatter point for the fixed function. It forces that cognitive shift.
Absolutely. It suggests that the bias is quite transient and highly dependent on the immediate context and success. Failure, in this specific case, actually acts as a crucial debiasing mechanism.
Okay, and finally on this study, we need to touch on the context of the testing itself. Did they have to, actively remind people of the tool's intended function during the puzzle session for the bias to kick in?
No, which again really shows the power of that initial functional label. Actively stressing the misleading functional information during the puzzle solving was not required for FF to occur. Simply having that recent functional knowledge, whether you just passively read about it or actively use the tool, was enough to bias the search process toward the standard use and away from those alternative physical uses.
This research also connects really nicely to something called the two-object paradigm, which visually demonstrates the mind's tendency to kind of avoid the recently used object, right?
Yeah, the two-object paradigm, which was developed by Birch and Rabinowitz, is a very clean way to show that avoidance behavior. Imagine you're presented with two tools that are, let's say, functionally equivalent in terms of their weight, maybe a relay and a switch. The problem you need to solve requires a weight, perhaps for the classic two-string problem. Now, if one of those objects, say the switch, has just been pre-utilized as, well, a switch, subjects will overwhelmingly choose the other object, the relay, to use as the weight.
Even though the switch is perfectly capable of being used as a weight, it has the right physical properties.
Exactly. The mind seems to be trying to solve the problem by minimizing functional conflict. It opts for the object whose function has not been recently fixed or primed. It confirms that the brain is actively seeking out a component that's free of that kind of functional baggage.
It's clear then that FF is a pretty robust psychological finding, at least within the laboratory. But let's talk about real-world utility and universality. Is functional fixedness purely a byproduct of our, technologically rich, standardized industrial society?
Well, that was the core hypothesis that German and Barrett set out to test in their 2005 study on the Shuar people in the Ecuadorian Amazonia. They wanted to test what they called the bricolage hypothesis. You see, in technologically sparser cultures, people are often forced to be supremely flexible with the tools they have. A single machete might be used as a weapon, a farming tool, a construction aid, maybe even a cooking utensil on different days.
So the expectation was that this lifelong practice of improvisation, of seeing tools constantly pressed into highly variable uses, would effectively inoculate the Shuar against functional fixedness, right? Compared to us in industrialized societies.
Yes, exactly. They hypothesized that this cultural practice of bricolage would promote a cognitive style that was less prone to fixedness compared to societies like ours, where tools are often highly specialized. This wrench only fits this one specific size of nut, that kind of thing.
And what did they find when they actually modified Dunker's box and spoon tasks for the Shuar adolescents they studied?
Well, contrary to the hypothesis, they found that the shore participants were susceptible to functional fixedness. They were significantly slower to select the target object when its primary design function had been primed, compared to the baseline condition where it hadn't. And the experimenters had really gone to great lengths to ensure cultural relevance, adapting the materials to be tools and objects familiar within the Shuar environment. But the results still held true.
Wow. That finding suggests something pretty profound then, that the cognitive architecture which assigns and represents a design function as a core property of an artifact, that it's likely universal to the human species.
It strongly implies that yes. It suggests that regardless of whether you're surrounded by highly specialized industrial tools or just a few versatile multi-purpose items, the moment your brain perceives an object's intended design function, well, that function acts as an immediate cognitive bottleneck when a novel use is required. FS seems to be kind of built into our fundamental way of organizing knowledge about artifacts.
Okay, let's push this universality even further then and look at non-human primates. Do apes, who often rely quite heavily on cultural knowledge for their tool use, do they suffer from a kind of functional fixedness too?
Yeah, research definitely supports the idea of what's sometimes called ape conservatism, particularly when they're dealing with novel tools. And this conservatism often seems to be driven by cultural learning, which acts a lot like fixedness. A great example comes from the honey trap experiment. Researchers basically placed inaccessible honey inside a log hole that required using some kind of stick tool to retrieve it.
And we're talking specifically about the Sanso chimpanzees in Uganda here, the ones who are known for lacking a stick tool culture for foraging, right?
Exactly, those chimps. When they were presented with sticks that could easily solve the problem, the Sanso chimpanzees largely failed to innovate using the sticks. Instead, they overwhelmingly relied on existing, known cultural behaviors. They actually adapted leaf sponging, a behavior they normally use to collect water to try and soak up the honey. This is pure conservatism in action, using a known fixed technique in a novel context, rather than innovating the necessary new function for this stick tool.
So they were essentially fixed on the cultural knowledge they already possessed, even when a more effective novel tool was right there available to them.
And we see similar kinds of challenges in orangutan data regarding the transfer of knowledge between tasks. Studies showed they had difficulty transferring skills between two related but different tasks, like, say, a honey dipping task and a raking task. If an orangutan used a stick for dipping in the first task, its behavioral choice in the second task, which required a different mechanical function for the same stick, was often hampered. This suggests their behavioral conservatism and failure to transfer functions are indeed linked to a form of functional fixedness, one that's tied to their acquired behavioral repertoire.
It's really fascinating how we see this pattern repeating across species and cultures. Now, let's pivot sharply to one of the most complex modern contexts imaginable: software engineering and design reuse. How does this kind of fixed thinking actually damage the development of digital systems?
Well, in software design, FF tends to manifest as extreme specificity, which leads to poor reusability down the line. Engineers, when they're solving an immediate problem, naturally tend to design components or functions that are perfectly tailored to that specific problem, and often that problem alone. They might see a block of code only as the solution to this specific bug they're fixing, not as potentially a generalizable, reusable function that could solve a whole class of related problems later on. The code effectively becomes functionally fixed on its initial purpose.
Right. And this means they end up having to rewrite complex code over and over again every time a similar but maybe slightly different problem comes up. So, what systematic solution has the literature proposed to actually combat FF in software design?
The primary solution discussed is a process called uncommitting design decisions. It's essentially a formalized analytical method designed to force abstraction. The idea is to strip away the specific constraints imposed by the immediate functionally fixed context. The goal is really to separate the core abstract logic from the transient context it was first developed in.
Okay, so what are the practical steps an engineer would actually take to uncommit a design? How does that work?
Well, the first step is usually challenging assumptions. You absolutely must ask fundamental questions. Why did we make this specific choice? What are the underlying alternatives we didn't consider? For example, if you're designing, say, a spreadsheet model, you might realize you initially just assumed an array view for representing the data. Challenging that assumption might reveal that the array is just one possible visualization. Maybe the core evaluation function actually requires more of a graph view for complexity analysis. Challenging the assumption opens the door to a more abstract, less fixed data structure.
Got it. So forcing alternative perspectives that move you away from that initial, maybe most efficient choice. What comes after that?
Second, it's about making implications clear. Once you challenge a fixed assumption, you have to really analyze the ripples. If you remove that array constraint, for instance, what does that imply for speed, for memory usage, for interoperability with other parts of the system? This step forces the designer to actually quantify the cost of sticking with the fixedness versus the potential benefit of abstraction.
And then the final crucial step seems to be abstraction through analogy.
Yes, exactly. Making analogies explicit. Functionally fixed solutions, when you analyze them across multiple different projects, often share some kind of common underlying abstract description. And this is where true reuse is often born. Take the famous quicksort algorithm. It's a highly specific, optimized way to sort data. Engineers eventually realized that the core mechanism, those inner loops that partition the data into two buckets, less than the pivot, greater than the pivot, could actually be generalized.
So they had to abstract the very concrete action of sorting into the more abstract action of just partitioning.
Precisely. By identifying that underlying commonality, the two-bucket partition, and then formalizing it into a reusable partitioning function, they captured a core domain concept. And that function could then be easily adapted for totally different tasks, like maybe creating an end partition, or even just efficiently locating the median element in a massive data set without fully sorting it. That shift from the fixed specific purpose quicksort to the abstract reusable function partition perfectly illustrates how uncommitting can shatter functional fixedness, even in these really high-stakes domains.
Okay, this deep dive has really established that functional fixedness isn't just some quirky lab finding. It seems to be a fundamental cognitive shortcut that our brains use for efficiency. It appears universal across species, it's embedded in our response to cultural knowledge, and it affects pretty much every domain from simple tool use right up to the architecture of complex software.
And importantly, we've also defined its crucial boundaries. It's maybe not the huge innovation killer we might assume when dealing with highly complex problems. And critically, its effect seems to dissipate pretty rapidly after just a single necessary failure. So maybe the problem isn't always a lack of tools, but rather the depth of our fixed knowledge about the tools we already have.
Right, so the key actionable insights seem clear. To overcome this bias, we probably need to cultivate a strong grasp of underlying physical principles, that intuitive physics you mentioned, and maybe actively adopt formal strategies like uncommitting design decisions to force abstraction. We also need to be mindful of those subtle environmental triggers, remembering that sometimes just using a word is more stimulating than showing a picture if you want truly novel thought.
Yeah, functional fixedness really reminds us that sometimes the most challenging part of solving a new problem isn't finding a new tool, but overcoming the sheer convenience of the established truth about the tools we already possess.
That leaves us with one final provocative thought for you, the listener, to chew on. If we know that the simple failure of a fixed strategy is often the key to unlocking new ways of thinking, what established rule or maybe highly optimized process in your own professional life might actually be a functional fixedness in disguise? And what single controlled failure might you be willing to risk, maybe even just hypothetically today, to potentially shatter it?